Okay, welcome to another Ginger Mathematician video. And so today I'm doing all of IGCSE Simultaneous Equations. So I have done all of IGCSE Algebra video before, you can check that out above. But today I'm focusing very specifically on simultaneous equations. And this is for IGCSE 058 Maths, but also works for 0607 Maths as well. So let's get started here. So the diagram's here, which shows angles in a triangle. And we have our two angles on a straight line. Notice I'm always underlining the key things here. The triangle is used to write down an equation in terms of x and y. So we have 2x plus 2y. So these two added together plus this added together gives us 180. And we need to give the reason for that. And the reason for that is, remember, all angles in a triangle, this is all you need to write down, in a triangle add up to 180 degrees. So we're exploiting that fact in order to actually create this equation. Now we can do a similar idea with the second diagram. So here, so use the diagram with two angles on a straight line to write down another equation in terms of x and y. And notice here, well, we have this angle and this angle. Angles on the straight line add up to 180. So we add together the x and we add together the 6y. Then we get 180 degrees. So that generates then the second equation that we were looking for. Now, once we have those two equations, so it's noticed this is called simultaneous equations because we have two equations with two unknowns and we want to find out both unknowns, so both x and y. So to do this question, I'm just going to write down the two equations from before. If you're liking this video, or you think you're going to like this video, once you finish watching it, then please do like and subscribe. So x plus 6y is equal to 180. Now notice the way that I've written this really lends itself really nicely to something called elimination. So I'm going to use the elimination method here. Mostly actually in the video I'll be using the other method, its evil twin, and that's substitution. Now the reason I like to use elimination here, so we take the two equations. What I'm going to do is going to take this second equation and multiply it by 2. So I'm going to multiply everything by 2 in this equation. So what's going to happen? Well, x times 2 is just 2x. 6y times 2 is 12y. And then 180 times 2 is 360. This makes my third equation that I'm going to use. Now I can do this because I have an equation. So whatever I do to one side, I do to the other. Now I'm going to copy down equation 1 here underneath. And this is where our elimination method is going to come in. Because what I'm going to do is I'm going to subtract the equations from each other. Now, what effect does that have if I subtract one from the other? Well, 2x minus 2x disappears. There is nothing left. And this is going to be very, very helpful. 12y minus 2y, that's just 10y. And then 360 minus 180 is 180. Notice by using this elimination method, I've eliminated, hence the word, one of the variables, so x in this case, leaving me just with an equation in y. Once I have this, I use my normal equation solving. 10y, well, the 10's kind of annoying. What's the opposite of timesing by 10? Well, divide by 10 on both sides. This cancels, giving us y, and 180 divided by 10 is just equal to 18. Now, some students will start celebrating at this point and go, yes, I've got the answer, y equals 18, but we're not finished because we do not have the x value. Now, we can substitute into any of these equations. I'm going to substitute and tell the examiner into equation 2. Again, there's no reason to choose 1, 2, or 3. I'm going to choose 2. So we have x. Now, I now know what y is, so I'm going to have 6 lots of y, which is 6 lots of 18. And that's equal to 180. Now, of course, if it's a calculator paper, you can use a calculator to do this, or we can use old school multiplying. So 8 times 6 is 48, 1 times 6 is 6, plus the 4 is 108. Again, if you're not so happy with that, you really need to be good with the multiplication and division, particularly with these non-calculator papers that are now either existing, so on 0580, or for 0607, it's now longer, so you need to be very good with that. We want x on its own here, so what's the opposite of adding by 108? We're going to minus 108 on both sides. This cancels, giving us x here. 180 minus 108 is equal to 72, which gives us then all 3 marks for this question. Now the great thing about these videos is if you think I'm going too slowly through it, you can increase this to 1.5 speed or 2 times speed. If you think I'm going a bit too fast, then you can decrease the speed as well. So please do use that underneath to make sure you've got the appropriate speed for this video. Right, here are the answers so you can check through everything that I've just completed. Right, on to question 2. This is more of an extended style question. Actually, a question like this came up in one of the very recent May 2025 papers. This is not the same question, but it's very, very similar. So the line here, y equals x plus 1, intersects the graph of y equals x squared minus 3x minus 11 at 2 points, A and B. So imagine you have a quadratic. Again, just to give you a visualization of what's going on here. And then we have a line. What we're looking for essentially is a intersection points over here. And with this information, we need to find both A and B. Now notice y equals x plus 1, y equals x squared minus 3x minus 11. So basically y is equal to both of these. Therefore, the right-hand side also needs to be equal. So we can say here that the x plus 1 over here, the right-hand side, must be equal to the right-hand side over here. So x squared minus 3x minus 11. If you're a German speaker, we call this Gleichsetzen. Again, if you're doing GCSE German, try and impress your German teacher by saying the word Gleichsetzen. Now, what we do from here is we want to solve this equation. Notice we have a quadratic because we've got this squared here. So we're going to have to use some of those skills that we saw in our algebra video. And generally, the method here, I'm going to switch over sides, and you'll see why I'm going to do that in a moment. You can do this with an equation because both sides are equal. I'm going to bring everything to the left-hand side. So what I mean by that, I want to make this right-hand side 0. So I'm going to minus x from both sides, and I'm going to minus 1 from both sides. So what effect does that have? Well, x squared doesn't change because it's not an x, it's not a number. Minus 3x minus x is minus 4x. Minus 11 minus 1 is minus 12. Be careful with negative numbers. And that's equal to 0. Now we have lots of different ways of solving simultaneous equations. We have factorizing, completing the square, the quadratic formula. So you can kind of choose which one you want to do. I'm a lovely espresso, by the way. What I would recommend is factorizing if possible and getting really, really good at it. So you're going to get a lot of practice in this video as well. So in order to factorize, the first thing we do is we set up our brackets, so we have x and x, and we want two numbers that multiply to give me minus 12, but add to give me minus 4. Again, you can write out some numbers, so 1 and 12, 2 and 6, 3 and 4. With a little bit of thinking about, we can go, 2 and minus 6, well, that works, gives me minus 12, and multiply them, and 2 minus 6 is minus 4. So we have plus 2, minus 6. And this is much quicker than using the quadratic formula, because now we can say either this bracket, so x plus 2 is 0, in which case x is minus 2, that's our first x answer, or x minus 6 is 0, and therefore x must be equal to 6. So this gives us the x coordinates of these intersection points. And in fact, I can actually write those in, so minus 2 and plus 6. But however, we still need to work out the y, and whenever you do a question like this, you should generally take the straight line equation. It's a lot easier to work with. So when x is equal to minus 2, that's our first answer, we put it into this formula. So wherever I see an x, I'm going to put a minus 2. Minus 2 plus 1 is just equal to minus 1. I can pop that in. And then when x is equal to 6, then we can pop it in as well. So 6 plus 1 is equal to 7, giving me all 4 marks for this question. I've realised actually by teaching last year that I say the phrase pop in quite a lot. Let me know in the comments if that is actually a thing that I say all the time. So we've got 2 answers, minus 2 minus 1 and 6, 7. Right, on to question 3a. Now, this is a pretty tricky one, but we're going to be using some of the ideas we've already seen. The first part is kind of standard here, so we're going to solve this simultaneous equation. Now notice we've actually got the q's the same, but we've got a plus q and a minus q. So if I try and subtract these equations like I did earlier, watch what happens. So 2p minus p is p, q minus minus q, 2 minuses make a plus, so q plus q is 2q. And then 2 minus minus a half is 2.5. Notice we don't get the elimination that we were looking for. So when we have a situation like this, where you have different sign, you have a plus q and a minus q, we're not going to subtract the two equations, we're going to actually add them together instead. Let's see what happens. So 2p plus p is 3p, q plus minus q is 0, it just disappears, and 2 minus a half, well, that's just equal to 1.5 or 1.5. Let's do 1.5 here. Then we do the same thing that we did before, so we can divide by 3 on both sides. So we can try and get that p on its own. This cancels, giving us p. 1.5 divided by 3 is equal to 0.5. You could also write this as a half as well. If you prefer working with fractions, that's absolutely fine. So we've got p here as 0.5. However, don't forget, we also need to work out the q. Now we can choose which one we want to substitute into, 1 or 2. I think this time we'll substitute into 1. Why not? So sub in 1. So wherever I have a p, I put a 0.5. So 2 lots of 0.5 plus q is equal to 2. 0.5 times 2 is just 1. 1 plus q is equal to 2. And therefore we need to subtract 1 from both sides. A really nice, easy equation. And that gives us then q is equal to 1. So we can pop that down like so. So 2 markers, so it shouldn't be anything too difficult. However, where it becomes a bit more difficult is this lovely 4 marker here, which links in some trig equations. And if you're not sure about trig equations, you just type into Mathematician, into YouTube, Mathematician, trig equations, you'll find my video on it. So it uses this word hence. So we need to do what we did last time, or use what we have last time. And we have u and v both between 0 and 360, solving this. Now you're thinking at first, your teacher has never taught you how to do this. Yeah, I've never been taught how to solve a sine and cosines like this. However, if we go back, notice it's actually in the same structure. If I write down the equations that we had before, 2p plus q is 2, p minus q is equal to minus a half. Notice the only difference here is instead of having p, get the trusty highlighter, we have a sine u. And instead of having q, let's get the trusty highlighter and let's go with a different color. So instead of having q here, we actually have cos v. So we can actually take our answers of p, which is the really clever thing about this question. So p was equal to 0.5. And that's just the same here as sine u. So actually we kind of solved this equation already. Q here was equal to 1, and that's equal to the cosine of v. So we've actually got some equations we can work with. So let's start with the easiest one. So cosine of v is equal to 1. Again, to solve trig equations here, we just need to find the inverse. So the opposite of cosine is inverse cosine of 1. And if we put that into the calculator, again, we actually get 2 answers here. If we think of the graph, we actually get 0 because the cos graph starts at 0. But notice it goes back to 1 at 360. Again, you need to know these graphs essentially off by heart. So we've got 2 answers here. We've got the one the calculator gives, but don't forget we've also got this answer over here because we are including 360. So v is equal to 0 and 360 degrees. You can pop that in. Now for the other one, so for sine, so let's pop that over here, little box. We have sine u is equal to 0.5. We start this in the same way. So we do the inverse of 0.5. And if you've been revising your exact values, you should probably know this off by heart. If you don't, it's time to learn it. You need it for the AA star questions. Then we get 30 degrees. So we can put that in. But remember, we don't actually have the other answer. The calculator's not clever enough to give that to us. But we can use the symmetry of graphs. So remember, the sine graph goes up and down, up and down. We've worked out this answer, so 0.5. I'm going through this pretty quickly because this is a simultaneous equations video. But notice we need to find that answer. And the way I generally teach this is, well, this distance and this distance are the same. It crosses the x-axis at 180 degrees. Let's use the red pen here. And so this one here, the answer we're looking for is 180 minus 130, which is equal to 150 degrees. Teachers will teach that slightly different ways. I'm tending to stick to graphs, avoiding things with the unit circle until you go into A level and IB. But again, you can use that as well to do these questions. So you can check the answers here and see everything that I have done so far. And if you're enjoying the way that I am teaching these topics and you're looking to get that last minute revision before your exams, then I've started my A-Star Accelerator Bootcamp. So this is literally the weekend before you do the exams, 4 hours on Saturday, 4 hours on Sunday, and we go through all those hardest topics. We also go through my predicted paper, so we go through a full walkthrough of both the paper 2 and paper 4 predicted papers. Again, that gives you that extra guidance on how to actually approach some of these questions, and also my unique tips that I've developed over almost 15 years now of teaching IGCSE. So if you're interested in that, again, it's in the description below. You can click on the online bootcamp, get yourself signed up. The next one is coming up on the 4th and 5th October. I'd love to see you there. Okay, on to question 4. So this is a slightly different kind of simultaneous equation, and notice we've been using mostly elimination so far, but we have the other method that you might be used to here, which is known as substitution. So this is a very good question to go through that kind of method. So notice here we've actually got y's and y squareds, which makes it very difficult to eliminate. So our elimination is not going to work, so I'm going to show you the alternative method, which is substitution. So this takes a little bit longer to do, but it works for pretty much everything. So I'm going to take my first equation here. So I've got x plus 2y equals 12. And what I'm going to do is start it in a similar way. So I'm going to times both sides by 5 here. Okay, and you'll see why we're going to do that in a moment. 5 times x is just 5x. Perfect. 2y times 5 is 10y. And 12 times 5 is 60. Now, what I'm going to do is put the 5x on its own. So what's the opposite of adding 10y? Well, that's minusing 10y on both sides. This cancels. This gives me 5x. And we get 60 minus 10y. So we've been doing a little bit of work with that first equation to get it in the form of 5x equals something. Now the reason for that is as follows, and it's similar to a question that we've already done earlier. Notice 5x is equal to this right hand side, and we have a 5x actually in the second equation. So wherever I see a 5x, I can replace it with this 60 minus 10y. If I do that, then we have 60 minus 10y plus y squared is equal to 39. And out of nowhere, we've actually got a slightly ugly looking quadratic equation, but in terms of y. So we can use the same methods that we have before in order to actually work out what y is. Again, we want the right-hand side to be 0 for a quadratic, so we minus 39 from both sides. 60 minus 39, now be careful with this. That's going to be equal to 21, not 31, so be careful. Minus 10y plus y squared is equal to 0. And hopefully your teacher has taught you we're working with quadratics. Generally, we order it as the y squared first, then the value of y, and then we have the number afterwards. So we put it this way. And again, we want to factorize if at all possible because it saves us a ton of time. So we set up our brackets with y's rather than x's like last time. And we want two numbers that multiply to give me 21, but add to give me minus 10. Again, you can write a quick list down, it's not a big list here. And notice we have minus 3 and minus 7, that gives us minus 10. And multiplying together gives us plus 21. So we actually drop out our answers very nicely. That means either y minus 3 is 0, therefore y is 3, or y minus 7 is 0, y is equal to positive 7. So that gives us our y values. Be careful here. We've actually only got the y values, so 3 and 7. And now we need to work out the x values, generally working with the linear equations. So this one here will make our life a little bit easier. So if we have x plus 2y is 12, wherever I see a y, well, let's start with the first value. So when y is 3, so 2 lots of 3 is equal to 12. This is a nice equation to solve. And that gives us, I'm going to speed through this a little bit more quickly than before. So x is 6. And then when y is 7, so x plus 2 lots of 7 is equal to 12, x plus 14 is 12, and so x is equal to negative 2. So again, taking those values of y, using this first equation, so I'm subbing into 1, we should probably label these 1 and 2, and then work out the values of x. So when y is 3, x is 6, and then when x is minus 2, let's be careful here, y is 7. You can write them either way round, that is also fine, and gives you a lovely 5 marks. Okay, there's the mark scheme, so you can see exactly how you go through it and collect those marks up as we go through. Okay, on to question 5. Again, if you're liking this video, then please do like and subscribe for more IGCSE content, and of course going into A-level and IB. So we have two graphs here, so y plus 5x is equal to 8, and y is equal to 2x squared plus 6x minus 13. They intersect at the points P and Q. Again, this word intersect is really important. It's the same thing here. We want to make the equations equal to each other. So that's what I'm looking for here. However, there's a little bit more work to do in this question compared to the previous one, because notice it's not y equals and y equals. We need to adjust the first equation so that we have y equals something. It's a very easy thing to do. We just minus 5x from both sides. That cancels. That gives us y equals 8 minus 5x. And now notice we have two equations where one equation is y equals 8 minus 5x. Y is equal to 2x squared plus 6x minus 13. That means then that we can make them equal to each other. So we can say 2x squared plus 6x minus 13 is equal to 8 minus 5x. If you remember the German word that I used before, then mention it down in the comments below and see if you can remember it and how to spell it, which is quite interesting. Anyway, let's go on. We've got a quadratic, this time with 2x squared, so it's going to be a bit more tricky than what we looked before. Notice we've got 6 marks now for the question. So what we want is everything to the left-hand side. So to do that, we're going to minus 8 and add 5x on both sides. The 2x squared stays as it is. Okay, x squareds we're not eliminating. 6x plus 5x is just 11x. Minus 13 minus 8. Again, be careful with those negative numbers, is minus 21. And that's equal to 0. Now, this kind of quadratic to try and factorize is usually a bit more difficult. Again, you can use the formula, completing the square, other methods. But I'm trying to build up those really quick skills. When you get to A-level and IB, you can do these questions much more quickly. So I still set this up in the same way. I still have 2x and x. And I still want two numbers that multiply to give me minus 21. So those things still stay as it is, and there's not many combinations either of that. But we need to be careful of when we expand this back, so to speak, that we are getting plus 11x at the end. So this takes a bit more experience to do and a bit more practice. I want a big 11x, so probably the bigger number is outside, so it multiplies by the 2x. So plus 7, and that means I need a minus 3 in here. Let's double check that. So if I do the outside terms, 2x plus times 7 is 14x, minus 3 times x is minus 3x. That gives me plus 11x. Okay, all is good in the world, and that does actually factorize like this. Now it feels like a bit like wizardry when I first do this, and if you want me to make a more detailed video on how I did that so quickly, then please do let me know in the comments below, and I can make a separate video just me practicing that kind of skill. I think I did a YouTube short on it as well. Now once we've got this, then we can then just work out the two answers. So either 2x minus 3 is 0. That means then 2x is equal to 3, x is equal to 3 over 2, or 1.5. So that's my first answer. And x plus 7 is 0, therefore x is minus 7. So we can put those answers in for x, so minus 7 and 1.5. And now we need to work out the y values. Again, we always try and take the linear one, so the one without any x squareds makes life a lot easier. So remember, y is equal to 8 minus 5x. So we can replace the x with these numbers one at a time. So we have y equals 8 minus 5 lots of 1.5. Okay, so that's 8 minus 7.5. Again, your mental maths is useful here to make sure you can do these questions nice and quickly. So we have 0.5. And we do the same now with the other value of x, so y equals 8 minus 5 brackets minus 7. Let's get rid of a pretty big number. Minus 5 times minus 7 is plus 35. These two things added together is going to give us 43. Super. And that gives us then all 6 marks for this pretty tricky question, generally towards the end of a paper 2 or possibly even the paper 4 as well. So you can have a look through the answers. Hey, they actually used the quadratic formula here as well, which is a very good alternative. Okay, on to question 6. This is the last question I'm going to go through, and then I'm going to leave a question or two for you to do, and you can let me know in the comments how you get on with it. So we've got simultaneous equations. Notice we can't eliminate because we've got this very irritating x squared here instead. So we have to use substitution, which you've seen in this video. So the way I'm going to do this, we've got 3x plus y is equal to 11. And I want to make the y look like minus 2y. So the first thing I'm going to do is multiply by 2. You'll notice I'm speeding up a bit in this part of the video. That's on purpose. So you're building up that fluency here. And then we need to have a minus 2y. So we need to flip all the signs. So we have minus 6x minus 2y is equal to minus 22. And let's get that minus 2y on its own. So the opposite of minus 6x is plus 6x on both sides. That cancels, giving us minus 2y is equal to 6x minus 22. So now we have it set up in a nice situation where we can replace the minus 2y here with the 6x minus 22. That gives us x squared plus 6x minus 22 is equal to 18. We've got one of those quadratics again. Oh, one of those. So we minus 18 from both sides. That gives us x squared plus 6x minus 40. Again, we'll just double check this. Equals 0. Again, we want to try and factorize and solve this. Again, you've got more combinations with 40, which is kind of annoying. So you've got 1 and 40, 2 and 20, 4 and 10. 4 and 10 looks good because 10 minus 4 is 6. So we go with a plus 10 and a minus 4. That gives us then plus 6. And that means then x is going to be either equal to 4 or x is equal to minus 10. So that's nice. These drop out very nicely. Doesn't actually put much for the answers here, so let's write this down as x equals 4, x equals minus 10. And now we want to work out the y part here. So again, we can substitute in. Let's substitute into this equation. So where we have an x, we put 4 to start with, equals 11. That gives us 12 plus y is 11. Therefore, y is equal to minus 1. Perfect. Super. And then the second equation here. So this time we have minus 10. So minus 30 plus y is equal to 11. So y is equal to 41. So no, it's just being careful here, not making any silly mistakes. You want to get all 5 marks on this question because now you've practiced this during the video, you should be a real expert on doing these kind of questions. Again, you can check through the answers here so you can have a look through exactly what you need to do. So have a go at this question for me. So this is question 8 here. See if you can complete this question. I'm not going to do that in this video, but write the answer down below. Again, we'll check whether you've actually got the answer to this pretty tricky question. You've got 2 lots of x squared and y squared, making it a little bit more difficult. Again, I'll give you the answers. So the answers are here, but how do you actually get through to the answers? That's what I'm interested in seeing. So if you've revised simultaneous equations and you're happy with this, but you want some more algebra practice, particularly some of that strange factorization I did with 2x squared, then check out the video right in front of you. That's going to help you a ton to get your algebra skills up to scratch for those upcoming exams.